Hey, hi guys, this is Mr. Urrego, and today we're going to learn some rational expressions. We're going to learn what they are, how to simplify them, how to find the domain, how to add, subtract, multiply, divide. Okay, so let's start. So let's simplify, and let's talk about what a rational expression is. So let's say that I have 3 over x minus 4. So rational means you have a fraction. That's the whole idea. When we talk about rational numbers, that means a number that you can write as a fraction. So 3 over 2, that's a rational number. 1 over 5, rational number. A whole number, any whole number is a rational number. Why? Because you can divide by 1. So this is rational fraction. Rational exponents based on the exponent. Alright, so rational expressions, we're going to have fractions. Expressions, because now my variable is going to be on the denominator. That's the whole thing. So if I have 3/4 of x, is this a rational function? Expression technically is not, because I don't have an x on the denominator. I have a leading coefficient of which is a rational number, a fraction, but the x is not on the denominator. All right, so rational expressions, you're gonna have a variable denominator somehow. Okay, simplify. Simplify is the same thing as we've done with many other equations. Is there anything that I can cancel from the top and the bottom, right? If I have a fraction, let's say 6 over 4, can I simplify this fraction? Yes. Divided by 2 is 3, divided by 2 is 2. I'm simplifying the expression. Can I simplify anything here? No. So technically that would be my answer. There's nothing that I can do. But now, every time I'm doing a rational expression, I gotta find the domain or the restrictions. So every time you write a rational expression, you give the domain or the restrictions to the domain. Okay, and what I'm saying is the following. The idea of the domain is what numbers are possible in this expression. What values of x can I plug in here so that my function is a real number? By the way, we're working on the real numbers, okay? You have the R like that. That's the set of real numbers. So let's do it again. Domain, what number can I plug in here on the x value that this will still be a real number, right? So think about it. 1, 2, 3, -1, any real number, any fraction, any number, any positive number, any negative number. But what's the limitation? So what happened is the following. I'm saying I'm looking for the restrictions. So by default, my domain is always the real numbers, all real numbers. But because this is a rational expression, what I'm going to do is I'm going to take the denominator and I'm going to make the denominator equal to 0. Okay, why am I doing this? Because let me ask you a question. I'm going to have 4 divided by 0 and I'm going to have 0 divided by 4. And I need to understand which of these two, what are the values here? Alright, what are the values for those two? So if I divide 0 divided by any number, my answer will be 0. I have $0 and I'm going to share with my 4 friends. Are they getting anything? No. 0 divided by any number is 0. But here comes the problem. Any number divided by 0, it's undefined. Undefined. I cannot divide by 0. Alright? So any number divided by 0 cannot happen. It's not possible. Your calculator is going to give you an error message. Alright? So, and that's the reason I'm looking for the values of x that will make my denominator equal to 0. So whatever is in the denominator, make it equal to 0. And from there, I find the value of x, which in this case is 4. So what I'm saying is, if I plug 4 in here, instead of the x, oops, look what I'm getting. If I get a razor, here you go. Okay. Color, here we go. So here I'm replacing the x by 4. which is the value that I got. 4 minus 4, 0. So when the x is 4, my function will turn to 3 over 0, which is undefined. And that's not possible. So the values that makes my function, my expression undefined is when the x is 4. Therefore, I don't want this. So my domain will be all real numbers except when the x equals 4. And that will be my domain here. Alright? For the most part, how do I write this on a regular basis? I write my function, x minus 4. I couldn't do anything else with this. And then I write my restrictions. And the restriction is x cannot be equal to 4, right? That's the exception. How do I write that? X has to be different of 4. This is my function, my expression, I'm sorry. X cannot, has to be different of 4. And that's how we write. Let's do one more. So now we have this one. X plus 7 divided by x squared minus 49 is a rational expression. Why? Because I have an x on the denominator. They're asking me to simplify. Okay, so guys, every topic has previous knowledge that you need to know. For rational expressions, you need to know two things: factoring, and here's a video about the whole factoring, and fractions. We need to know how to add, subtract, multiply, and divide fractions. And now rational expressions will be a combination of those two. Alright, and those are the two videos. I'm going to link them on the description of this video, and at the end I will link them so you can check them out. So factoring. When I'm simplifying a rational expression, the first thing that I want to do is to factor anything that I can. I come over here to x plus 7. Can I factor? No. By the way, I'm going to go quick through all the factoring because you got to go check. You got to be not a master, but you need to understand your factoring. So make sure you go back to that video and check all the factoring. Right now, this is a difference of squares. How can I factor a difference of squares? I got two factors, x and x, plus and minus. The 49 turns into 7 and negative 7. Okay, so now I have this. Some people said, oh, let me cancel the x plus 7 from the top and then the x plus 7 from the bottom. Yes, we'll do that. But the first thing that I need to do is to find the restrictions to the domain. And my restrictions are any values that will make my denominator 0. So what I do is I bring my denominator x plus 7 times x minus 7 and I make it equal to 0. And from here I find the value of each. So I'm going to have x plus 7 equals 0 and x minus 7 equals 0. This is left minus 7 minus 7. X is going to be equal to negative 7. The other side, plus 7, x equals 7. So what did I just find? People get confused. Oh, that's my domain. No, remember, these are the values that will make my denominator 0. So these are the things that I do not want. This is the restrictions, okay? So here we go. Now, my domain is all this, all real, except negative 7, except positive 7. I don't want those two values. Those are my exceptions. All right. So once I have my domain on my my original function, then I come back. This is okay. Can I simplify? Yes. Top and bottom. What do I have left? I have 1, x minus 7. But what's my original domain? My restrictions. Then I put over here, comma. My first restriction is when the x is negative 7. My second restriction is when the x equals 7. And this will be your final answer. Okay? Your simplified form, but the domain, the restrictions are from the original problem. Right? Let's work on another one. So now I have this. Simplify x squared plus 12x plus 36. On the bottom, x squared minus 36. Is a rational function? Yes, I have an x under my denominator. What's my first step? Factor. That's what I need to do. On the top, I have a trinomial. That trinomial is going to break into 2. x squared is x and x. Two numbers that you multiply, you get 36, but when you add, you get 12. 12, 3, 9 times 4, 6 times 6, here we go. 6 times 6, 6 times 6 is 36, 6 plus 6 is 12. Alright, the bottom, I have a difference of squares. Two factors, the x squared breaks into x and x, a plus and a minus, the square root of 36 is 6, and 6. Factor everything. You see that I can cancel, right? Before I do that, I go back and I do my restrictions. Alright, so let's do the restrictions in red. I bring my denominator. This is what I bring. I don't care about the top. I don't care about numerator. My denominator, x plus 6, x minus 6, and I make it equal to 0. Each factor equal to 0. Minus 6, minus 6. My first value is negative 6. The second value, plus 6, x equals 6. These are the ones that I don't want. Let me bring over here. Okay, now I got my restrictions. So these are the ones that I don't want. I can go back to my original here, and then I can simplify whatever I can. Now I have x plus 6 over x minus 6. The number one question that I ask is, guys, can I cancel this x and then this x from the bottom? And the answer is no. That's a common mistake. Every time you have a plus or a minus, this becomes 1. This becomes 1. You can just take the x by itself. When you have a plus or minus, now this is 1 unit. This is 1 unit. A common mistake here is that people will cancel those x's. Be careful with that. Simplify, simplify. X plus 6 on the top, x minus 6 on the bottom. Bring my restrictions. Comma. X cannot be equal to negative 6. X cannot be, right, different. This is equal. Line across is different. Cannot be equals to 6. And that's my answer. As you can see, we're factoring a lot. Make sure you check the factoring. Alright, let's move ahead. Multiplication. Okay, let's multiply two rational expressions. How do we multiply rational expressions? Or how do we multiply two fractions? Top with top, bottom with bottom. That's it. Now, are we going to do FOIL? No, we're not going to multiply the whole thing. Remember, every time we have this type of expressions, we factor because we want to cancel something from the top and from the bottom. How do I multiply fractions? Top with top, bottom with bottom. So technically, look what I need to do. Extend the line. I just multiply. Boom. That's it. I multiply the top and the bottom. What's next? Factor whatever you can. Can I factor the x minus 7? No. X minus 1? No. X squared minus 1? Yes. So let's keep the x minus 7 as a factor. And the x minus 1 is a difference of squares. I'm going to have two parentheses. X and x plus and minus, square root of 1 is 1 and 1. And I just factor this out. The bottom, x minus 1, I'm bringing that one. This, I see that I have a greatest common factor of 3. 3 is in the 21, so 3 is a common factor. 3x divided by 3 is x, minus 21 divided by 3 is 7. Oh, you see that? X minus 1, minus 7, minus 7. Before I do that, don't forget the restrictions. It's really important to do the restrictions as soon as you see that. Okay, so am I concerned with the numerator? No, the denominator is the one. Always my denominator. So I'm going to bring the x minus 1. Let me bring that 3 in the front because it's bothering me back in the middle. Alright, I just moved to the front. Doesn't matter because they're multiplied. X minus 7, and I make all that equal to 0. When I have a number, it does not matter. 3 equal to 0 doesn't make sense. So when I'm making equal to 0, is my factors. X minus 1, the ones that have a variable next to it. X minus 7. These are my factors. Okay, I have a value of x. The 3 does not matter. If I divide by 3 on both sides, the 3 will cancel out. X minus 1 equals to 0, x minus 7 plus 1, x equals 1 plus 7, x equals 7. Hopefully by now you understand. I don't want this. I don't want them. Alright? So now that I find my restrictions, remember these are your restrictions. You have to. This is part of the domain that we don't want. As soon as we find this in my original function, I go back and it says, alright, x minus 7 is gone. X minus 1 is gone. What's left? X plus 1 over 3. Nothing else. Done. And then, comma, my restrictions. I don't want this one, and I don't want that 7. X has to be different of 1, X has to be different of 7. Okay? Any other value except the 1, except the 7. That's the most common way how to write those things. Another way you can write this, technically, you can write domain. It's all real. Except when x equals 1, x equals 7. Another way, domain. All real. And instead of writing except, you just write x has to be different of 1 and x has to be different of 7. Right? Most common in textbooks is this. You just write the restrictions. Other teachers or professors that will ask you for this. Alright, let's do another multiplication. Or not. That was funny. Division. Let's do the division because it's kind of the same thing. Let me explain. So I'm dividing two rational functions, right? That's my division sign. But again, I'm going to use fractions. That's why you have to go back to fractions. How do I divide fractions? So let me give you a real quick example here. Let me divide 1/2 divided by, I don't know, 3 over 5. Okay? This is, a simple way. What do I do? It's something that's called keep, I think. Keep, what is the words? Keep, change and flip. There you go. Keep, change, and flip. I'm keeping the first fraction. I'm changing the sign, and I'm flipping the second fraction. 1/2. Keep, change. Instead of division, I'm multiply. Flip. Instead of 3 over 5, I'm going to flip. And once I have this, now I know that I just multiply across. 1 times 5 is 5, and 2 times 3 is 6. So this is what I'm going to use for this. So let's do that. Keep. So I'm going to have all this. And that's why I didn't do the second example for multiplication, because we're going to keep multiplying. Keep, change, instead of division, multiplication, flip. Instead of x over 3 over 1, we do 1 over x plus 3. Keep everything in parentheses so you don't get confused. How do I multiply? Straight across. So the only thing that I need to do is just extend the line, and now I know that I'm multiplying everything. Okay? Alright, let me build on this. What's next? Factor. Okay, so I have a trinomial on the top. So let's factor that. 2 parentheses. Two numbers that multiply give me 9, and you add, I get 6. That x squared breaks into x and x. My numbers are 3 and 3. 3 times 3 is 9. 3 plus 3 is 6. Denominator. Can I factor this? Yes, that's the sum of cubes. The pattern. Cube root of this, which is x. Cube root of 27. And then my second parenthesis is going to be this to the second power. Change the sign. First time the second. Square the second one. And I need some space right there. Alright. There's nothing we can do. That's a pattern. Nothing that we can do. We just did this. Now I need to bring that the x plus 3. And now I have everything factored. By the way, when we factor a sum of cubes or a difference of cubes, there's nothing else inside this parenthesis, because I always say when I'm factoring, check every single parenthesis. But with this pattern, there's nothing we can do with this. Alright, that's all my factoring. Now, my restrictions. So, to find the restrictions, remember, you make your denominator equal to 0. Here, and the reason I did this problem is because it's interesting. Alright? Let's see if I can fit all this over here. I bring my denominator equal to 0. So I'm going to have x plus 3 and all that. X squared minus 3x plus 9. And then x plus 3 equal to 0. Okay, do I need to copy x plus 3 twice? No, I know that the restriction, if it's here, is the same thing. Okay, just to say, keep that in mind. So, because I'm going to have x plus 3 equal to 0, this is just going to be the issue, and that's the reason I did this problem. And then the x plus 3 equals 0. Minus 3, minus 3, negative 3, same thing here. So I don't want the negative 3, right? That's one of the values. But what about here? Can factor, okay? So if I want to find the values, and I'm going to do it once to make sure that you understand that. So x squared minus 3x plus 9. I don't have space to do what I need to do. If I want to find the values of a quadratic function, right? The easiest thing that I want to do is I'm going to say the distance formula. No, the quadratic formula. Let me show you. So I need space for this one, so let's get to the next screen. So quadratic formula. By the way, I call this your new BFF, right? It's huge. It's very important. It's very useful. X equals negative b plus or minus square root of b squared minus 4ac over 2a. What is all these a and b's? My standard form of a quadratic is this. And I'm going to go quick through this. I'll do another video for quadratic formula and all that stuff. This is my function, x squared minus 3x plus 9. Look, x squared minus 3x plus 9. I put it underneath so I know how much is a, how much is b, and how much is c. And c is equals to 9. A in front of the x squared, b in front of the x, c is your constant. I'll come over here. It says negative b. Negative, how much is b? Negative 3. Plus or minus. B squared. Negative 3, parenthesis, squared. Minus 4 multiplies the a. A is 1. And the c, right, is 9. Everything over 2 times a from the denominator. 2 times 1. And now I just need to solve all this. Right? So let me go quick through this. So this is the quadratic formula. It's very important, very useful. Negative negative is going to be positive, and on the inside I'm going to have negative 3 squared, which is going to give me 9. Negative 4 times 9 is negative 36, and the bottom is going to give me 2. Right? So let's keep going. X equals, I'm going to the right. Okay? X equals 3 plus or minus 9 minus 36 gives me negative 27 if I'm not mistaken. So over 2. And here I stop. Remember, my restriction, let me see if I can go back. My restriction is all the, I'm looking at the, I don't have it here. Okay. When I'm doing my domain, I'm working on the real numbers. Okay, I have a negative inside a radical. This is imaginary number. Imaginary number. So this is not a real number anymore. So cross that out. That's not part of my restrictions because now this is an imaginary number. Okay, not a real number, which my domain is working on. All right, later on you work more on complex numbers, and this is a complex number, imaginary number. Okay, so that's the reason I'm not taking this restriction, because it's not a real number anymore. It's an imaginary. So let me go back. So the solution to all this, 3 plus or minus, so x equals 3 plus or minus negative 27. By the way, I'll explain imaginary numbers in a different video. Complex, all about complex numbers. And the over 2. All right, not a real number, so that's not a restriction. So my only restriction was the negative 3. That's the only restriction that I have in this problem. Therefore, let's simplify and write the restriction. Simplify. X plus 3, x plus 3, 1 from the top, 1 from the bottom. Make sure. Nothing else on the top, and the bottom I have this, because there's nothing on the top, I need to put a 1. Final answer, 1 over x squared minus 3x plus 9. My restriction, x cannot be equal to negative 3. Alright? A little bit complex. I give you a difficult problem, but again, factoring. Let's do one more. So let's divide this one now. We have this divided by that. Let's put parentheses to make sure that we don't make mistakes. Alright? So keep, change, flip. And then we factor. So x squared minus 2x plus 1 over x cubed plus x. Keep, change, flip. The bottom goes to the top. The top goes to the bottom. And now you're thinking, how can I factor each one of them, right? Factor, factor, all of them. Remember, I'm multiplying, I just need to extend that line, because now this is multiplying that, because there's no signs in between, so you multiply, just in case. Factor. Two numbers that you multiply, you get 1, but when you add, you get negative 2. Okay. So there's two choices. 2 positives give you a positive, but 2 negatives give you a positive. So my answer is x and x. Negative from here, negative times positive is negative. My two numbers are 1 and 1. Negative 1 times negative 1 is positive 1. Negative 1 minus 1 is negative 2. The bottom. GCF, I guess. Cube divided by x is x squared plus x divided by x is 1. Extend. Here, I guess GCF as well. 3 is a common factor. 3x squared divided by 3. 3 divided by 3. And we can notice, we can see things equal, right? The bottom, another trinomial. X squared is going to break into x and x. Two numbers, you get negative 1. But when you add, you get positive 1. So, positive and negative, that's going to give me 2. Oh, this is 2 times 1. 2 times negative 1 is negative 2. 2 minus 1 is 1. And my factor. Restrictions. Okay, my restrictions. Here we go. All this equals to 0. So x equals to 0. Let me do an extra step. That's fine. All my denominator equals to 0. X equals 0, nothing that we can do. X squared plus 1 equals 0. X plus 2 equals 0. X minus 1 equals 0. Excellent. X equals 0. That's it, nothing we can do. X squared plus 1. So minus 1 minus 1. X squared equals negative 1. Square root. X equals plus or minus. Can I do the square root of negative 1? No, that's an imaginary number. Imaginary. Not part of my real numbers. Minus 2 minus 2. X equals negative 2. Okay. And I'm sorry for this thing. This is x minus 1 equals 0. It's horrible. I'm so sorry. Plus 1 plus 1. X equals 1. And now I have my restrictions. 1, 2, 3. The middle one, square root of negative 1. This is I. So it's not a restriction on the real numbers. Let's go back. Simplify. I got my restriction on my original. Don't forget. X squared plus 1, top and bottom. Let me see what else. X minus 1 with 1x minus 1 only. Anything else that I can simplify? No, I don't see anything else. So let's go. From the top, I got a 3 and the x minus 1. 3 and the x minus 1. From the bottom, I have an x and I have an x plus 2. Can I reduce any of that? No. So normally, or sometimes you're gonna get this as an answer. For the most part, they want you to multiply back. They want you to multiply back whatever you have remaining. That means x times x is x squared and then times it. So this is the right answer. Don't get me wrong, this is fine. But for the most part, books will not give you this. Books will give you multiply back. Okay? Once you have your expression, then I bring my restrictions. My restrictions, I hope the restrictions are clear by now. They have to be clear. It's huge. X cannot be 0. What else? X cannot be negative 2. X cannot be equal to 1. 3 restrictions. And that's it. Alright, let's get to adding and subtracting. Adding and subtracting, a little bit more easy, I think. Let's find out. Again, guys, if you're here with me, please subscribe. You're going to have that right over here in this corner. Around that corner, bottom corner, the subscription button. Okay, like the video. Stay with me. We're going to add and subtract right now. Let's go. Now we have addition and subtraction. So we have rational expression, rational expression. Alright. Same thing as fractions. An irregular fraction. So what do we have? So let's pretend that I have, I don't know, 1/3 plus 5/3. What is the requirement of fractions? They need to have the same denominator. Once they have the same denominator, you keep, and then you add the tops. And then you simplify. And that's it. Same idea. Okay? Do I have the same denominator? Yes. But again, as a rule of thumb, you might want to do always, keep in mind, you want to always factor. Start from the beginning. Because at one point you have to factor anyway. So this is a difference of squares. I'm going to have an x plus 3 times x minus 3. Okay? And then I have a 4x minus 2, and the bottom is x plus 3, x minus 3. Okay? Are they the same? The denominators. Oh, I made a mistake here. This is a minus, not a plus. Okay, so are the denominators the same? Yes, they are the same. So I keep my denominator, x plus 3 times x minus 3, and I do whatever in the top. Meaning, I have 5x plus 1 minus, because I have a minus here, I want to put a parenthesis here. If you know what, let's put parentheses on both. So let's try to avoid mistakes. X plus 1 minus 4x minus 2. The reason I did this is because now I have 5x plus 1. There's nothing in front of this parenthesis, so I can get rid of it. But this negative will change the sign of the 4 and the sign of the 2. Very common mistake. Same denominator. Let's keep going. Let's simplify the top. 5x minus 4x, then I have an x right there. 1 plus 2 is 3. And I just finished the top. I'm ready to simplify more. I'm ready to simplify the top and the bottom. Right now I just did the top, right? Because I'm subtracting. Before we do this, remember, restrictions. Okay, so let's get rid. Restrictions, x plus 3, x minus 3. Hopefully by now you can do this on the side, right? You know that it is going to be the opposite of positive 3, which is minus 3. So, and it's going to be the opposite of negative 3, which is plus 3. Those are little things that you'll start, as you practice, you get to know them. Opposite sign, negative 3, opposite sign, positive 3. Restrictions. Let's go back to the original. Cancel, cancel. If there's nothing left on the top, then you have a 1. And x minus 3. My restrictions. I don't want the negative 3, I don't want the 3. I don't want the negative 3. I don't want the positive 3. So if you notice, I'm repeating a lot of things that we did in the beginning, which is simplifying the domain, the restrictions. All right, so we're going one step at a time. The factoring is huge. All right, let's do one more. So now we have an addition. Do I need to write the word? No, I don't have to. I have a plus. Rule of thumb: factor. Factor from the start. x plus 3 stays the same. The bottom, trinomial, x and x plus and minus 2 times 1. 2 times negative 1 is negative 2. 2 minus 1 is 1. I'm okay. Remember, there's no number, you have a 1 right there. Plus, difference of squares, x and x plus minus. Guys, every time I'm doing these problems, stop me, okay? Try to solve it yourself. Start the video, try to solve it, and then check if you got the right answer. All right? Next, fractions. Do I have the same denominator? All right, here we go. So this is the main thing. And let me give you a quick example on the side. I have 1/2 plus 1/3. All right, do I have the same denominator? No, I don't. So what I need to do is get the same denominator, right? Which is the LCD, least common denominator. I'm going to show you an easy way how to do that. Fractions again. I want the same denominator. So I know that 2 times 3 is 6. So 6, in this case, will be my least common denominator. Okay, from 2 to 6, by one number do I need to multiply 2 to get to 6? I got to multiply times 3. Whatever I do on the bottom, I do on the top. 3 times 2 is 6. 3 times 1 is 3. The next fraction plus the next fraction, 1/3. How can I get 3 to 6? I got to multiply times 2 on the bottom, 2 on the top. 2 times 3 is 6. 2 times 1 is 2. Final answer, I keep the same denominator and I add the tops. And that's my answer. Same process will follow here. Do I have the same denominators? No, I don't. I need to have the same denominators. So because this is factors, all right, factors, I want to see what's in common. I have the x minus 1 here and I have the x minus 1 there. All right, so I'm going to bring the x minus 1 as one of my factors. X plus 2 is here, but it's not here. Still, I need to bring it. X plus 2, and I'll make a little line here and a little line right there. All right, and a dot here, just to make sure that we understand where things are coming from. So I got the x plus 2, I got the x minus 1. I don't have the x plus 1. I got to bring the x plus 1. X plus 1, and let's put 2 dots on the x plus 1. So I got all the 3 factors. This is my least common denominator. That's how I get my common denominator. I bring whatever's in common, and whatever is not common, I bring them also. So I gotta bring for both fractions the same denominator. X minus 1, x plus 2, x plus 1. It doesn't matter what order I have because all of them are multiplying. So when you multiply 2 numbers, it doesn't matter the order. All right, next. This denominator, the same that I did here, remember? By one number do I need to multiply the 2 to get to the 6, and I multiply on the side? All right, I want this denominator to be the same as this. What's missing? X plus 2 is there, x minus 1 is here, all the x plus 1 is missing. That means I gotta multiply x plus 1 here, and the x plus 1 there, like the 3 and the 3. And now, x minus 1 is here, x plus 2 is here, and the x plus 1 is there. It doesn't matter the order, as long as I had the 3 factors. And now I have on the top, x plus 1 times x plus 3. All right, parentheses, just in case. Go to the next fraction. I have the x plus 1, right? I have the x minus 1. I don't have the x plus 2. That means I gotta multiply x plus 2 on the bottom and x plus 2 on the top. And now I have my 3 factors on the bottom. That means I gotta multiply 2 times x plus 2. That step is huge. That's the whole thing. Once you get this, now it's just going back to the previous steps that we did. Now my denominators are the same. Now it's just a matter of adding or subtracting whatever I have on the top. All right? So it's algebra again. So let's keep the same denominator. Let me write the same denominator, and then we do the top. Here we go. So it's going to be x, oops, x, oh my god, hold on. Much better. X minus 1, x plus 2, x plus 1. Now I'm doing this final step. I'm adding the tops, okay? So, but before I need to add, I got a 2 parentheses here. Now, my top only the top. All right, I gotta solve that. That means I gotta do FOIL here and then distributive property here. X times x, x times 3. You can do that on the side if you want. 1 times x, 1x, 1 times 3. Be careful here. You know what? I'm gonna do an extra step right there. Because this, if it's a negative, then it's gonna affect everything on the top. Okay? Be aware of that. Be careful here. My suggestion is to put 2 and then x plus 2 and then distribute. So you're aware that this sign is going to change whatever you have here. Because it's a positive, it doesn't matter to us. Extra step, doesn't matter. Keep the same denominator. X minus 1, x plus 2, x plus 1. Let's do this step. So I'm going to have x squared. Alright, let's combine whatever we can right now. 3x and x is going to give me 4x. And then this 3, let's hold on to that 3. And let's distribute. 2 times x is going to give me 2x. And 2 times 2 is going to give me 4. Alright, we need more space. So I have this. I moved to the top so I need a little more space. So let's combine like terms. I got an x squared. I have a 4x and 2x, that's going to give me a 6x, and then I have a 3 and a 4, that's going to give me a 7. So for the most part, okay, I'm going to be able to factor the top, and then I can cancel something with the bottom. In this case, I'm thinking, product, 2 numbers that you multiply get 7, but when you add you get 6. You see there's 7 and 1, and that's it. And 7 and 1 is not going to give me, 7 and 1 is not going to give me 6, alright? What I just said was 7 times 1 is 7, but 7 plus 1 is not 6. So there's no 2 numbers that you can factor to get the sum 6 and the product 7. So this will be my final answer. Now, once we answer, like I said, most of the time we're going to be able to cancel on the top and the bottom. Once there's nothing else you can do, then we go back to the restrictions. So we're going to get x minus 1, x plus 2, and x plus 1. Everything equals to 0. By now, I hope you remember that it just basically changes the sign. I have x minus 1 equals 0, x plus 2 equals 0, and x plus 1 equals 0. Changing the sign, plus 1, x is going to be 1. So we're going from negative 1 to positive 1. X plus 2, minus 2 minus 2, x equals negative 2. And here, x plus 1, minus 1, and the value is negative 1. So, final answer, restrictions on the side. X has to be different of 1. X has to be different of negative 2. X has to be different of negative 1. And that will be my answer. Now, that was the process for adding and subtracting. We multiply, we divide, everything else. The next step will be just doing complex numbers. And complex numbers is, it's a big topic itself, so that will be our next video. Right now, the main idea is for you to remember that we need to factor. So I'll be linking the factoring of those videos. And here, on the sides, you'll see a video for factoring and a video for fractions. Please don't forget to subscribe. You're going to have the subscription button all there, just throughout the video. Alright guys, please subscribe, like the video, hit the notifications bell, and I'll see you in the next one. Take care. Thanks for watching. Bye-bye.